Welcome back to another episode of Second Career Pilot.
Yeah.
As a new pilot, one of the most just mind-blowing things is realizing that you're actually controlling this huge machine up in the air.
It really is.
It is amazing.
Today we're going to dive into the world of aircraft flight control systems,
Okay.
and really sort of break down how you as the pilot actually make this metal bird soar through the sky.
Yeah, it's a fascinating area, and especially for someone new to aviation, just to realize how much thought and engineering has gone into making these things
Yeah.
controllable and safe.
Yeah, it's really remarkable.
It is.
So we're going to be looking at everything from the basic surfaces like, those things on the wings and tail that move,
Yeah.
to the more complex systems that assist pilots in controlling the aircraft.
Right.
So let's get right into it. So when we talk about flight controls, we're essentially talking about how a pilot manipulates the aircraft's attitude
Yeah.
and movement in the air.
Yeah.
And there are two main categories that we're going to focus on today: primary and secondary flight controls.
Yeah. That makes sense.
Now, those primary flight controls, those are kind of like the essential ones.
The absolute essential.
Yeah, the ones you absolutely need to basically fly the plane.
Right.
So let's start with those. What are those primary flight controls, and what do they do?
Well, the primary flight controls are the ones that give you direct control over the aircraft's orientation in 3 dimensions. And those dimensions are what we call roll, pitch, and yaw.
Right.
So the first one we can talk about are the ailerons.
Okay.
And these are located on the trailing edge of each wing.
So that back edge.
Yeah, the back edge of the wing.
With the wing. Okay.
And they move in opposite directions. So when you move the control wheel or the stick to the right,
Okay.
the right aileron goes up and the left aileron goes down.
Okay, so they always move in opposite
Oh,
directions.
correct.
Yeah.
And this difference in deflection changes the lift on each wing. And that's what makes the airplane bank or roll.
Okay, so if I want to roll to the right,
Yes,
my right aileron goes up, my left aileron goes down.
that's correct.
Okay, and that makes the right wing drop and the left wing come up.
Yeah, that's exactly right.
Okay, got it.
Now, there's a little bit of a side effect that happens when you use the ailerons.
Okay, what's that?
And it's called adverse yaw.
Adverse yaw.
Oh.
Okay.
And this is a little bit counterintuitive, but it happens because when you deflect an aileron downward to increase the lift on that wing,
Okay.
it also increases the drag.
Oh, okay. So more lift.
More lift equals
Drag.
more drag. And at the same time, the aileron that's going up to decrease lift on the other wing
Right.
is also decreasing drag.
Got it.
So this difference in drag between the two wings,
Okay.
which we call differential drag, causes the aircraft to yaw or swing its nose in the opposite direction.
Of the intended roll.
So if I'm banking to the right,
yeah,
it's going to try to yaw me
to the left.
to the
one,
little.
a little bit. Yeah.
Yeah. Okay, that's interesting. So how have engineers gotten around that? Because that seems like it would make things really tricky.
Right. Well, there's actually quite a few clever solutions that engineers have come up with to minimize this adverse yaw. And one of the
Okay.
common approaches is something called differential ailerons.
Differential ailerons.
And with differential ailerons, the upward deflection of one aileron is greater than the downward deflection of the other one for the same amount of control input.
Okay.
So it means that the wing that's creating more lift
Yeah.
is also creating more drag,
Even more drag.
which helps to balance out the yaw.
Got it.
Another solution is something called freeze ailerons.
Gary's ailerons.
And these have a little protruding edge that sticks out into the airflow when the aileron is raised.
Okay.
And this creates drag on the upward moving aileron,
Oh, I see.
which helps to counteract the adverse yaw.
Okay, so it's like a little mini spoiler.
Yeah, you could think of it that way.
Got it.
Some aircraft also have coupled ailerons and rudder.
Okay.
And this means that the ailerons and the rudder are mechanically connected.
I see.
So when you move the ailerons, the rudder automatically moves a little bit in the opposite direction to counteract the yaw.
So that's done for me. I don't even have to think about it.
You have to think about it. It happens
Oh,
automatically.
that's cool.
And then finally, some aircraft have something called flaperons.
Flaperons. Now that sounds like a combination.
It is a combination. It's a combination of flaps and ailerons.
Okay.
And so they can act as both flaps to increase lift and drag during takeoff and landing,
Okay.
and as ailerons to control roll.
So it does double duty.
Exactly.
That's cool. Okay.
So those are some of the ways engineers have addressed adverse yaw.
Wow, that's a lot of different solutions.
Yeah, it's a problem they've been working on for a long time.
Yeah, that makes sense.
Okay, so moving on to the next primary flight control, we have the elevator, or sometimes you'll see something called a stabilator.
Okay, elevator, stabilator, what's the difference?
Well, they both essentially do the same thing. They control the pitch of the aircraft.
So the up and down movement.
Exactly, the up and down movement of the nose.
Okay.
On most smaller aircraft, you'll find an elevator, which is a separate hinged surface located on the trailing edge of the horizontal stabilizer.
Okay, so it's like a little mini wing.
Yeah, like a little mini wing on the back.
Off the back. Okay.
Detail.
All right.
When you pull back on the control column, or the yoke, the elevator moves upward.
Okay.
And this creates a downward force on the tail,
Got it.
which causes the nose to pitch up.
Okay, so pull back, nose goes up.
Exactly.
Push forward, nose goes down.
Correct.
Got it.
Now, a stabilator, on the other hand,
Yeah.
is a single one-piece horizontal tail surface that pivots as a whole unit.
Oh, okay, so the whole thing moves.
The whole thing moves.
Interesting.
Because the entire surface is moving. A stabilator is usually more sensitive than an elevator.
Oh, okay, I see.
And to manage the sensitivity and also to provide a means of trimming the aircraft stabilators, often incorporate something called an anti-servo tab.
Anti-servo tab now? Is that kind of like the trim tabs we were talking about with the ailerons?
It is similar to a trim tab, but it works a little bit differently.
Okay.
A trim tab on an elevator moves in the opposite direction to the elevator,
Right.
but an anti-servo tab on a stabilator moves in the same direction.
Oh, okay, so the opposite.
Yes.
Right.
And this helps to make the control less sensitive and also to hold a particular pitch attitude once you've trimmed it.
Oh, okay. That's pretty neat.
Yeah, it's a clever system.
All right, and then you also mentioned T-tails.
Right.
I've seen those on some aircraft where the horizontal stabilizer is up on top of the vertical stabilizer.
Exactly. It makes a T-shape.
Yeah.
And T-tails have some advantages.
Okay, what are those?
One is that the horizontal stabilizer and elevator are located higher up and out of the way of the wings and propeller. So they're less affected by the turbulent airflow or downwash that comes off of those surfaces.
So it's cleaner airflow up there.
Cleaner airflow.
Okay.
This can result in a smoother, more stable pitch control.
Okay, that makes sense. And then I've also noticed that a lot of aircraft with rear-mounted engines have T-tails.
Yes, that's another advantage of the T-tail design.
Okay, how so?
It keeps the horizontal stabilizer and elevator out of the exhaust from the engines,
Which would be bad.
which could definitely affect their performance.
Yeah, that makes sense. Are there any downsides to a T-tail?
Well, there are a couple of things to be aware of.
Okay.
One is that T-tails can sometimes require greater control forces at lower airspeeds.
Okay.
And another potential issue is something called a deep stall.
Deep stalled. Okay, that sounds bad.
Can be.
Yeah.
Yeah. It's a situation where the turbulent airflow from the stalled wing can blanket the horizontal tail surfaces,
Oh, wow.
making them ineffective.
Oh, wow.
This is more likely to occur at high angles of attack,
Yeah.
and especially if the aircraft is loaded with a center of gravity towards the rear.
Oh, that makes sense. So they're further away from the wing. So if the wing stalls, that turbulent air could kind of get up there.
Exactly.
Yeah, that makes sense. So are there ways to prevent that or mitigate that?
Yeah, there are some design features that can help.
Okay.
Some aircraft with T-tails have something called elevator down springs,
Okay.
which are springs that help to push the elevator down and prevent a deep stall.
Okay, so even if the airflow is disrupted, those springs will still help to push the nose down.
Exactly.
Oh, that's a good backup.
It is.
Okay, so we've talked about the ailerons and the elevator or stabilator.
Right.
What about the last of the primary controls? The rudder.
Oh, yes, the rudder.
What does that do?
So the rudder controls yaw, which is the side-to-side movement of the aircraft's nose.
Okay.
You control the rudder with your feet using the rudder pedals.
Oh, okay, so this is the footwork.
This is the footwork, exactly.
And how does that work?
So when you push the left pedal forward, it moves the rudder surface on the vertical stabilizer to the left.
Okay.
And this creates a side force that pushes the tail to the right and the nose to the left.
Okay, so left pedal, nose goes left.
Exactly.
Got it.
It's important to remember that the rudder's effectiveness is directly related to airspeed.
Okay, how so?
Well, the faster you're going, the more air is flowing over the rudder,
Right.
and therefore the more force it can generate.
Okay, so at slower speeds, the rudder is less effective.
That's right.
And then I've also heard that in propeller-driven aircraft, the propeller slipstream can actually make the rudder more effective.
That's true.
How does that work?
The propeller slipstream is the spiral of air that comes off of the propeller.
Okay.
And when this slipstream hits the rudder, it can increase its effectiveness.
Oh, okay. So it's like giving it a little boost.
Exactly.
Okay, that's interesting.
Yeah.
Okay, so we've talked about the ailerons, the elevator, and the rudder.
Right.
Those are the three primary flight controls.
The big three.
Yeah, but you also mentioned something called a V-tail.
Oh, yes. Some aircraft have V-tails
Hmm.
instead of the traditional horizontal and vertical stabilizers.
Right.
And a V-tail essentially combines the functions of the elevator and rudder into two slanted control surfaces called ruddervators.
Ruddervators, okay.
These ruddervators are mounted in a V shape on the tail,
Okay.
and they move together to control pitch and differentially to control yaw.
Oh, so it's like a 2-for-1 deal?
Exactly.
That's pretty cool.
It is a very cool design.
Are there any like disadvantages to having a V-tail?
One thing to keep in mind is that the control system for a V-tail is more complex than for a conventional tail.
Okay.
And V-tail aircraft can sometimes be a bit more susceptible to a phenomena called Dutch roll.
Dutch roll, what's that?
Dutch roll is a type of coupled lateral and directional oscillation.
Oh, okay, that sounds complicated.
It can be, but basically it's a back and forth rocking and yawing motion.
Oh, I see.
It's usually not dangerous,
Okay.
but it can be a bit uncomfortable for the passengers.
Yeah, I can imagine.
Okay, so that covers the primary flight controls.
All right, so those are the ones that we absolutely need to fly the plane.
Exactly.
But then we also have the secondary flight controls.
Right.
And what are those all about?
So the secondary flight controls are surfaces that aren't strictly necessary for flight,
Okay.
but they enhance the aircraft's performance
Got it.
and reduce pilot workload.
Okay, so they make things easier and more efficient.
Exactly.
So what are some examples of secondary flight controls?
Well, some of the most common ones are flaps,
Flaps.
leading edge devices,
Okay.
spoilers,
Okay.
and trim systems.
Trim systems. Okay, let's start with flap.
All right, so flaps are located on the trailing edge of the wings,
So that back edge again?
the back edge, yeah.
Okay.
And their main purpose is to increase lift and drag at a given angle of attack.
Okay. Now, why would we want to increase drag?
That's a good question.
Yeah.
Well, during takeoff and landing, we want to be able to fly at slower airspeeds.
Right. For safety.
For safety, exactly.
Okay.
And flaps allow us to do that
I see.
by increasing the lift and drag of the wing.
Got it.
There are a few different types of flaps.
Okay. What are those?
The simplest type is called a plane flap,
Blade flap. Okay.
and it's just a simple hinged section of the trailing edge that deflects downward.
Okay. Simple enough.
Then you have split flaps,
Okay.
which are similar to plane flaps, but only the lower surface of the flap deflects.
Okay.
Slotted flaps have a gap or a slot
I see it.
between the flap and the wing, and this slot allows high-energy air from the underside of the wing to flow over the top of the flap,
Okay.
which helps to increase lift and delay airflow separation.
So it makes them even more effective.
Yes, more effective.
And then there's Fowler flaps.
Right. Fowler flaps are the most complex type of flap.
Okay.
They're similar to slotted flaps, but they also extend rearward on tracks.
Oh, wow. So they change the shape of the wing.
Exactly. They change the shape and the surface area of the wing.
And that allows for even more lift at slower speeds.
That's right.
Okay, so Fowler flaps are kind of like the heavy hitters of the flap world.
You could say that.
Okay. Now, what about leading edge devices?
So leading edge devices are located on the front of the wings.
Okay, so the opposite of the flaps.
Right, the opposite end.
Got it.
And their main purpose is to improve the airflow over the wing at high angles of attack.
Okay, so like during takeoff and landing.
Exactly.
And what are some examples of leading edge devices?
Well, one common type is a fixed slot,
Fixed slot.
which is basically a permanent gap in the wing's leading edge
Okay.
that helps to smooth out the airflow.
Got it.
Then you have movable slats,
Okay.
which are kind of like mini flaps on the leading edge
Okay.
that can extend forward to increase the wing's camber.
Got it.
And then there are also leading edge flaps,
Leading edge flaps.
which are similar to trailing edge flaps, but located on the front.
Got it.
And finally, some aircraft have leading edge cuffs, which are fixed aerodynamic modifications to the leading edge that improve the airflow at high angles of attack.
Wow. So there's a lot of different ways to manipulate that airflow.
There are.
Yeah.
It's all about getting the most lift possible,
Yeah, especially at those low speeds.
especially at low speeds.
Okay, so we've talked about flaps and leading edge devices.
Sure,
What
sure.
about spoilers?
Spoilers are kind of the opposite of flaps and leading edge devices.
Okay, how so?
Their purpose is to actually disrupt the airflow over the wing.
Okay, so they reduce lift?
They reduce lift and they increase drag.
Okay, now why would we want to do that?
Well, spoilers have a few different uses.
Okay.
One is to control the rate of descent on gliders.
Oh, okay.
Spoilers can also be used to assist with roll control on larger aircraft.
Oh, okay, so they're kind of like extra ailerons.
Yeah, you can think of that way.
Okay.
And because spoilers don't create lift on the opposite wing like ailerons do,
Right.
they can help to reduce or even eliminate adverse yaw.
Oh, I see. So they're a way to control roll without getting that unwanted yaw.
Exactly.
Okay, that's clever.
And then finally, spoilers are also used after landing
Okay,
to help
yeah.
slow the aircraft down
Got it.
by dumping lift and increasing drag.
So they kind of spoil the lift?
They spoil the lift, exactly.
Okay, that makes sense. And then lastly, we have trim systems.
Yes, trim systems.
Now, these are all about making the pilot's life a little easier, right?
That's right.
Because you don't want to be constantly fighting the controls.
Exactly.
So what exactly do trim systems do?
So trim systems are designed to relieve the pilot from having to constantly apply pressure to the flight controls
Okay,
to maintain a desired flight attitude.
I see.
The most common type of trim system uses trim tabs,
Trim tabs, okay.
which are small movable surfaces located on the trailing edge of the primary flight controls.
So kind of like mini versions of the ailerons and elevator.
Yeah, you could think of them that way.
And how do those work?
So by adjusting the trim tab, you create a small aerodynamic force
I see.
that helps to hold the primary control surface in the desired position.
So you're basically fine-tuning the control surface.
Exactly.
And how do you control the trim tabs?
Well, it varies from aircraft to aircraft.
Okay.
But typically you'll find a small wheel or a lever in the cockpit
Okay.
that you use to adjust the trim.
Got it. Now, I remember you were explaining earlier that to trim the elevator for a nose-up attitude, you actually have to move the trim tab down,
Yes, that's right.
which seems a little counterintuitive.
It does seem counterintuitive.
But it's because the airflow over the downward deflected trim tab
Right.
actually pushes the entire elevator up.
Exactly. It's all about the aerodynamic.
Yeah, that's so cool. Okay, so we've talked about trim tabs. Are there any other types of trim systems?
Yes, there are a few others worth mentioning.
Okay.
Balance tabs are similar to trim tabs,
Okay.
but they move in the opposite direction to the primary control surface.
I see.
And their purpose is to reduce the amount of control force that the pilot needs to apply.
Oh, okay, so it makes the controls feel lighter.
Exactly. Lighter and more responsive.
Okay, that's cool.
Then you have servo tabs,
Servo tabs, okay.
which are small tabs that are used to move the primary control surface indirectly.
Indirectly.
They're typically found on larger aircraft,
Okay.
and they work by using aerodynamic forces to move an actuating rod or linkage
I see.
that then moves the main control surface.
Okay, so it's like a force multiplier.
Exactly.
And then we've already talked about anti-servo tabs, which are used on stabilators.
Right.
Are there any other trim systems out there?
Yes. A couple more.
Okay.
Some aircraft have ground adjustable tabs.
Ground adjustable tabs, okay.
These are tabs that are bent on the ground by maintenance personnel
I see.
to adjust the trim for specific flight conditions.
Okay, so those are not something that the pilot adjusts in flight?
Correct. They're adjusted on the ground.
Got it.
And then finally, some larger aircraft have adjustable stabilizers.
Adjustable stabilizer.
Okay. Which means that the entire horizontal stabilizer can be moved to adjust the pitch trim.
Oh, wow. So instead of just adjusting a little tag,
Right.
you're adjusting the whole stabilizer.
A whole thing.
That's pretty amazing.
It is.
Okay, so we've covered a lot of ground here
Yeah.
with all these different control surfaces and trim systems.
A lot of moving parts.
Yeah, for
Yeah.
sure. And I think it's really incredible how all these systems work together
It is.
to give the pilot such precise control over the aircraft.
It's a testament to the ingenuity of the engineers who designed these systems.
Yeah, absolutely.
Cool.
So as a new pilot, learning about all this can feel a little overwhelming.
I can imagine.
But it's important to remember that you don't have to know everything about how these systems work to
Right.
be able to fly the plane.
Exactly.
The most important thing is to understand the basic principles
The basic.
and how to use the controls effectively.
And to always refer to the aircraft's flight manual.
Right, of course, the pilot's operating handbook.
Yes, the POH.
Because every aircraft is a little different.
Everyone is unique.
Yeah, so the POH is your best friend.
Absolutely.
And as you gain experience, you'll develop a deeper understanding of how these systems work.
And a better feel for the aircraft.
Yeah, for sure.
Yeah.
So yeah, I think that's a great overview of aircraft flight control systems.
I think so too.
Thanks for breaking it all down.
My pleasure.
And for our listeners out there, keep practicing.
Yes, keep learning.
And always strive to improve your skills.
And most importantly, have fun.
Yes, absolutely have fun.
Yeah.
Thanks for listening.
Thanks for having me.
We'll see you next time.
See you then on Second Career Pilot.